Hello guys, welcome back to my YouTube channel. So today we will be solving three very interesting and tricky questions from the topic geometry, and all these three questions came in CAT 2008. So without wasting any more time, let's start with the first question. Consider an obtuse angle triangle with side 8 centimeter, 15 centimeter and x centimeter. If x is an integer, then how many such triangles exist? Okay, so if you have solved similar kinds of question earlier, this question won't be any hurdle, won't create any hurdle for you. But if you are facing this kind of question for the first time, then this might look like a very difficult question. But trust me guys, this is a very simple question. Okay, although this is a tricky question, it's an interesting question, but this is not a difficult question at all. Trust me, once I solve this question, you will definitely agree with me that this is not a difficult question. Okay, I will put this question as a easy or easy to moderate. Okay, so first, forget about obtuse. Okay, we are told that this is a triangle, so there is a simple property of triangle which states that sum of any two sides of a triangle is greater than the third side, right? I will write the property: sum of any two sides of a triangle is greater than is greater than the third side. Okay, and there is also a very important property which states that difference, okay, difference of any two sides of a triangle is less than the third side, less than the third side. Okay, and please note this difference is the bigger side minus the smaller side. Okay, when you are taking the two sides, right, any two sides, please make sure that when you are subtracting from the bigger side. Okay, so now so x is the third side, this is the third side, this is less than the sum of any two sides, basically 15%. First property, sum of any two sides of a triangle is greater than the third side, and difference of any two sides of a triangle is less than the third side. Okay, I have used property 1 and property 2. Okay, so this will be 7, right? 7 is less than x less than 23. Okay, very important relation we have derived till now. Please note x is an integer. Okay, integer can be positive, negative, and can be 0 as well. But guys, please note x is the length. X is a length. Okay, this is a length, so this will always be greater than 0, right? That means what? X belongs to natural numbers. X belongs to natural number or positive integers, or you can say positive integers, right? So what are the possible values of x till now? Till now we can say x can be 8, 9, 10, 11, 12, like that, right? Till 22, right? Till 22. That means with these values of x, I can form a triangle. But what is the question? The question is obtuse angle triangle, guys. Obtuse angle triangles. So now we have to use another property, third property here. Okay, and this is a very important property in obtuse angle. In an obtuse angle triangle, third side. Okay, or I would say third side is not the correct term. I will say, okay, this will be longest side. Okay, longest side, square of the longest side is greater than the sum of the squares of the other two sides. Okay, sum of the squares. So side 1, let's say I have side 1 square plus side 2 square. Okay, the longest square of the longest side is greater than the sum of the squares of the other two sides. Okay, this is a very important property. Now let's see what we can derive from it. Now guys, either we have the sizes 8, 15, x. Out of this, definitely 8 cannot be the longest side because we already have 15, which is greater than 8. Also, we can also have x as greater, right? Because x can be 17, 18, 19, 20, 21, 22, right? That means what? X can be greater than 15 as well. From here, we will have two cases. Okay, guys, we'll have two cases. What is the first case? Longest side, longest side is equal to 15, and in the second case, longest side is equal to x. Now, if 15 is the longest side, then I can say 15 square is greater than x square plus 8 square, or I can say x square is less than 15 square minus 8 square. This will be x square is less than a square minus b square is a minus b into a plus b. So x square is less than 1 to 161. That means x can take 8, 9, 10, 11, 12. X cannot be 13, guys. If I take x equal to 13, 13 square is 169, and 169 is greater than 161. Right? So till now, these 5 values of x are possible. If x is the longest side, then x square is greater than 8 square plus 15 square. 8 square is 64, 220, 15 square is 225. So 220 plus 60 is 280, 284, 289. 289. So this is 17 square, right? 17 into 17. That means x must be greater than 17. So these are also possible, right? 17 to 22. So how many numbers are there? 5 numbers are there, right? That means x cannot be equal to 13, 14, 15, 16, 17. These are the 5 values of x that is not acceptable. Alright guys, that means how many such triangles exist? 10. Your answer will be 10. These 5, 8, 9, 10, 11, 12, x can be 8 or 9 or 10 or 11 or 10, or it can also be 18, 19, 20, 21 or 22. So there are 10 possible values of x for which the given triangle will be an obtuse angle triangle. Alright, so there are 10 such triangles. A very good question, a very interesting question, not a difficult one, easy to moderate. Okay, moderate because many students fail to acknowledge the two cases. Okay, they directly do use the first and second property, and from 8 to 22 they include all the values, but we are told it's an obtuse angle triangle, so we will have to take into consideration the third property as well. Okay, that is why I have told you moderate, or else it's easy question only. So easy to moderate. Let's move on to the next question. Okay, so two circles both of radii 1 centimeter intersect such that the circumference of each one passes to the center of the other. What is the area of the intersecting region? Okay, let me first draw the diagram. Okay, because in geometry if you draw the diagrams, the question becomes clearer. It becomes clear.
they both the circle passes to the center of each, right? So okay, let's say this is the center of the first circle and this is the center of the second circle. Let me denote the centers as C1 and C2. So I need to find the area of the intersecting or the common region, right? Common region. Let me say this point as A and this point as B. I need to find this area. Okay. Alright. So I will join these points. Alright, guys. Join these points. And these are the radius, right? C1 from center C1 to point A. Point A is on the circumference of the circles and C1 is the center of the first circle. That means what? C1A is the radius. Radius is given as 1 centimeter. That means what? That means this side, this is 1 centimeter. Similarly, this is also 1 centimeter. This side is also 1 centimeter. This side is also 1 centimeter. And this will also be 1 centimeter, guys. C1 and C2. Why, guys? See, if I consider the first circle or the circle whose center is C1, okay, focus on this circle whose center is C1. From C1 to C2, C2 lies on the circumference of the first circle. That means what? C1, C2 is the radius of the first circle. Similarly, C2 is the center of the second circle and C1 lies on the circumference of the second circle. That means what? C2, C1 is also the radius of the second circle and the radius of both the circles are 1 centimeter. That means what? C1, C2 is also 1 centimeter, right? That means this is an equilateral triangle. This side is 1 centimeter, this side is also 1 centimeter and this side is also 1 centimeter. So this is an equilateral triangle. That means this angle is 60 degree, this angle is 60 degree, this angle is 60 degree. Similarly, this angle will be 60 degree. All the angles here will be 60 degree, right? All the angles will be 60 degree, right? So what will be the area, right? What will be the area of the common region? So the area of the common region will be, see, now guys, let's denote the area. Let's say this is 1, okay, region 1, this is region 2, okay, and these are symmetrical, right? These are symmetrical. If I find the area of any one of these segments, any one of these segments, and then multiply by 4, I will get the total area, right? Now, what is an area of an equilateral triangle? Root over 3 by 4 side square, root 3 by 4 side square, and we have two equilateral triangles, so multiply by 2. So I will have root 3 by 2, side is 1, 1 square will be 1, so root 3 by 2. This is the area of 1 plus 2. 1 plus 2, okay. This is not the number 1, this is the region, okay. Region 1, regions. 1 plus 2 will give me area root 3 by 2. Now I have to find any one area of the segments. Let's say I find the area of this segment, okay. I will find the area of this segment. I am marking in yellow color, okay. What will be the area? So let me draw another circle so that you guys can understand this question. Let's say we have a circle and let's say this is the center, okay. Now this is point C2, right? I have C2 here and there is A, right? A is there, okay, and C1 is also a point on the circumference. So if I join this, okay, my bad, this will be C1, okay. I am considering the circle C1, okay, C1. So this is C2, this is C1. If I consider the first circle, guys, okay, first circle, so C2 and A are C2 and point A. Both these points are on the circumference of the circle whose center is C1. So C1, C2, A. Okay. Now I'm joining this, right? And I need this area of this segment. What is the area of this segment? Area of segment is given by some. Now this angle is theta, let's say. So how do you calculate the area of a segment? Theta divided by 360 degree pi r square minus area of this triangle. This will give me the area of the entire sector. Sector means this entire part. Okay, this entire part. Okay, this is the sector. I will get the area of this entire. From this sector, I will subtract the area of the triangle C1, C2, A. So half into C1, C2. Let's say this is R. This is also R. So half R square sine theta. Okay, half AB sine theta. Area of a triangle is given by half AB sine theta, where theta is the included angle between the sides. So what is theta? Theta we have already calculated, this 60 degree, right? Theta is 60 degree. 60 by 360 will give me R is 1, so pi by 6 minus R is 1, sine 60 is root 3 by 2, so root 3 by 4. That means this is one of the area. Similarly, the other areas will also be equal, so I will multiply entire thing by 4. What will be this? Pi by 3, this is 2 minus root 3. This is the area of the segments. This is 1, this is 2. So add 1 and 2. So 1 plus 2 will give me the total area. So 2 pi by 3 plus root 3 by 2 minus root 3. So this will be 2 pi by 3 minus root 3 by 2. 2 pi by 3 minus root 4. This is the required answer. A very good question. Very good question. A moderate level question. Okay, guys. I hope you have understood. Okay. So let's move on to the last question for today. In a triangle ABC, okay, so let me draw a triangle ABC. Let's say this vertex is A, this vertex is B, this vertex is C. The length of sides AB is 17.5, AC is 9. D is a point on line segment BC, so the AD is perpendicular to BC. Okay. This is 90 degree, this is D. And the length of AD is 3 centimeters. Then what is the radius in centimeter circle circumscribing the triangle ABC? That means I have a circle that is circumscribing the triangle ABC, and I need to find the radius of this triangle. I need to find the radius of this triangle. Okay. All right. So easy question. So what is the relation between the sides of a triangle and the circumradius? So the circumradius R, okay, this is given by product of the sides of the triangle divided by 4 times the area of the triangle. I will prove this, okay guys, don't worry, I will prove this. So what is A? A is the side opposite to angle A or vertex A. Vertex A. So entire BC equal to A. What is B? B is small b, okay, small b is this side opposite to angle B. So AC equal to B. And similarly, what is C? C is the side opposite to angle C. So AB equal to C. Alright. So in place of A, I will write BC. In terms of B, I will write AC. In terms of C, I will write AB by 4 into A. What is A? Area of a triangle is half into base. What is the base? BC. What is height? Height is AD. Right? Now see, BC, BC, cancel. So AC, what is AC? AC is 9. What is AB? 17.5. What is AD? AD is 3. This will get cancelled. 3, 1. So 3 by 2 into 175 by 10. So 5 into 2, 5 into 3, 25. So this is 15, 9, 10 by 4. This is 4 into 2 is 8, 25. So 24, 6.25. 26.25 centimeter is the required answer. Already as a very simple question if you know the formula. Okay, but now I will prove you, okay, from how we got this. Okay guys, so for this you must know the sine rule. Okay, sine rule, sine rule. So yes, in a triangle, a by sine a is equal to b by sine b is equal to c by sine c equal to 2 times of the circumradius of the triangle. Okay, and area of a triangle. Okay, this is suppose a triangle. Let's say A, B, C. This is small b, small c. This is small a. Okay, this angle, this angle. Okay, this angle is A. So area of a triangle is given by, the area of this triangle will be given by half into B into C into sine of angle A. This angle will be the included angle between the sides. So B and C. What is the included angle? This angle. Alright. So now see, half into BC, I will keep it as like that. What is sine A? From the first sine rule, sine A can be written as A by 2R. A by 2R. A B C upon 4R. See, simple derivation. Okay guys. I hope you have understood all the 3 questions, and I hope you have learned something new from this video. Uh, Please do like the video and subscribe to my YouTube channel for more such interesting questions, and I will see you in the next video. Thank you guys.